Hi all, welcome back to Cracking the FAANG interviews. Today I'm going to be solving an Amazon interview question. It's called Count Negatives, the number of negative integers in a row-wise and column-wise sorted matrix. And the question has also been asked at Facebook interviews as seen in Leetcode interview experiences. I couldn't find this problem on Leetcode, so I'm gonna go in much detail and try to explain the problem first. What you're given is a 2D array or a 2D matrix, right, as you'd like to call it, which has rows and columns. And you're asked to find the number of negative integers in row-wise and column-wise sorted array. And in this case, in this example, let me explain what do we mean by a row-wise and column-wise sorted array first. So row-wise and column-wise sorted array matrix. So as you see, we are sorted in ascending order for each of the columns here, and same for the rows. We are in increasing order from -3 to 1, -2 to 4, 4 to 8. So this is what has been given to us. This is a row-wise and column-wise sorted matrix, and we are trying to find the number of negative numbers. So what if this wasn't the case, right? If we would not have this property of row-wise and column-wise sorting, how would we find the number of negatives? So what we do in that case is go through each element of the given matrix and simply count the negative integers. The runtime of this would be O of m into n, which is a quadratic, which can be approximated as a quadratic time complexity to make this easier to understand. And we can do the same for this question as well. There's, it will work. You will be able to find, the number of negatives. But we've been given this interesting property of row-wise and column-wise sorted array. My question is, how do we use that and do better? So, every time we get to this question on how can we do better, we are at quadratic. What is better than quadratic? We can do linear, right? So if you want to get to linear, how do we use this property is essentially the question. And this is going to be the optimal solution as well. Now you know your array is row-wise and column-wise sorted. Let's try to see how we can do the finding. So I'm going to put some indexes here. I'm going to say I have a pointer I and I have a pointer j, perhaps, and I is index of 0, 1, 2, meaning there are 3 rows. J is index as 0, 1, 2, 3, meaning there are 4 rows. So if I were to start initialize both of these here, since my negatives are on the left and I want to start from the positives perhaps. So I start here, for example, and I go to my first negative, right? I check if this element is negative. If it is, I know how many elements exist because I know the indexes. I can simply count, but that's not the case. This is a positive, so I go to this index. I hit my first negative, and I'm able to count. So I'm able to count using end minus start plus 1 as the number of negatives, right? So what this means is here end, the first index, as I want to call it, or j in our case, is 2. The start index is 0, and you do a plus 1 since you're 0 index. So the total number of negatives is 3. So I can simply just hit the first negatives because the array is sorted and see how many negatives are there in the row. Once I know that, I increment my I pointer to the next row. So I come here. Do I see a negative? No. So I move my j. I decrement my j pointer. I move towards the left. I still don't see a negative. I continue my search. I find it here. Now j is 0. So I calculate using this formula. So it's gonna be 0 minus 0 plus 1. So there's 1 negative. So by now I found my 4 negatives. but I still need to complete the search. So I'm at this negative number. I go downwards from here and check at 4. There's no negative. I'm simply gonna end my loop and I'll get go out of the fall off the cliff in terms of my pointers. Now I want you to observe how was I able to do this, where I didn't start back here, but I simply just went downwards from where I found the first negative. It's because your columns and rows are sorted. Since there is a -1 here, I'm guaranteed there's going to be an increasing number here and nothing less than -1. So I really don't need to go back in time and check for that. I hope that made sense. This is the general concept of the problem and the approach that we are going to follow. So how much work are we actually doing or saving, right? So we said we started with quadratic complexity, and I'm claiming this to be close to linear, right? So what we do is, if you think about it, we're gonna go from right to left, which is m, for example, and we sort of made a jump here, right? And then we went all the way here, we made a jump here, and so on. So in the worst case, you might not have found any negative, and you'd go all the way here and then jump all the way here, which is n. So the amount of the total number of distance you're sort of covering, or the elements you'd cover in the worst case, would be O of m plus n, which is the row width and the column width. So as you see, I took O of m into n, to be more precise, a quadratic program, and I converted them into a linear program using the property given to me of sorting. And something I want to establish, so you can reuse these concepts whenever you're given something that is sorted. Always think of removing duplication and binary search. So here we are not using binary search. It's not going to help because you might have to repeat it over and over for each row, which doesn't make sense. But you can always remove duplication of checks, given the order in which numbers are arranged and the properties given to you. I'll jump into writing code for this all right. So the way this will look like, again, I'm going to quickly draw the example. We are given this matrix -3, -2, -1, 1, and -2, 2, 3, 4, and the last row is 7, 8. Let's say this is my I pointer, this is my j pointer, this is of size m, this is of size n. So I'm going to write def count negatives, and I'm given this matrix m, and I'm given the dimensions of the row and column m and n, and I'll start with a count variable which I'm going to increment and count. I'll start from 0, so I'm starting from row 0, and j is going to start from m minus 1 because I'm starting from the last column. The reason I do that is I'm looking for negatives. I know, if I start here, my negatives are always going to be on the left or where I start, right? Whereas if you would have started here, you would have to go all the way and come back. So that's not really helping. You'd still end up doing a quadratic amount of work if you start here. So best to start here, given the property. And the way I'm going to do this is I'm going to write a while loop. While j is greater than equal to 0, meaning while you go all the way here and I is less than n, because I is incrementing. So while I also falls off the cliff and j also falls off the cliff, what I do is I check if each element I am looking at is negative. If I found a negative element, as I said, I simply increment my count and also jump to the next row. So let me fix this. Also jump to the next row. Else, if that's not the case, I keep moving to find my negative by decrementing j. And in the end, once I'm done with the loop, I return count. Awesome. I hope this program made sense, and the time complexity in the worst case is of m plus n, since you'll travel uh, all the distance here, right? And all the distance, m row and column distance. Um, Thank you for watching yet another video from Cracking the FAANG Interviews. This was an Amazon interview question, and I hope you like, share, and subscribe to our channel for more